you've been going through methods for solving simultaneous equations. So would you remind me of what they are, please? So finding simultaneous solutions. We went through more than one way of doing it based on whatever situation we're given. So you can remind me by giving me an example if you like. Pardon? That's part of a whole process. What was that process called? Elimination. Okay. We solved by elimination. Although that's the first one you've said, it's actually the last one we did. Okay.
Substitution.
Yeah. So we also solved by substitution. Right.
Multiplication.
Well, within elimination, we had to multiply, didn't we? It wasn't a method in its own right. So while we were doing elimination, we thought, well, we have to multiply. Does that make sense? Solve by substitution. The first one we actually did was kind of like substitution, but okay. So in your notes, on their own, those three things won't mean an awful lot to you, but with all the examples we've done, they should do. But we've got those methods. There is actually another method that we haven't done a lot of, but we know about, which is solving by which you can do by hand or you can do by, that was part of the elimination. Pardon? Well, you can use your calculator, but how do you use your calculator? What? Solve by graphing. Okay. Now you can use your calculator to graph, or, which we were doing before this, you can draw graphs by hand. Find out where they cross. Okay. So don't forget, we've got all those things you've been able to do. We're now going to look at forming the equations and then solving them. So when we get into solving, there's nothing new. We need to use some of those methods. Okay. So now it's about forming the equation, which I have to say comes with a bit of practice. Okay. Not an awful lot of variation in the questions, but they can be hard to get your head around, so practice makes easy. Alright, so let's have a look. What we'll do is we'll go through the examples on page 164 and 165 together first, and then I'll let you move on. Okay, so example 19. Let's have a look. So we've been given this piece of information. Two numbers have a sum of 45 and a difference of 13. Okay, so two numbers have a sum of 45 and a difference, okay, of 13. Find the two numbers. So we're going to do this by setting up simultaneous equations. So, two numbers. What can we use to represent the two numbers? X and Y. So I'm just going to write X and Y, maybe number 1, number 2. And then we look at, well, we've got an equation for information point number 1 and we can find an equation for point number 2. So, who thinks they could already write an equation for number 1? Sum of 45. Yeah? So x plus y. X plus y equals 45. So I've taken the information from the question. You all know that sum means plus, difference means subtract. And then the values are 45 and 13. So we've got our 45. What about the second equation? Get it. Think it through very carefully, though. You've got to think it through. Y minus x. Right. Does it matter whether it's y minus x or x minus y?
Not at the moment.
Not at the moment. Okay. Will it matter?
Yes.
Because?
One's going to be a different answer.
Yeah, one's going to be bigger than the other. Okay. So we could do y minus x. We could write x minus y is 13. But we need to be very careful with this one that, you know, the one that we state x and y, you know. Do we want to write y minus x therefore, or do we want to write x minus y at this stage? Why would you choose to write x minus y rather than y minus x?
QR is TW.
Yeah.
X comes before Y.
The alphabet doesn't play any part in our algebra like that. So. Okay. Well, for me, I would be saying, well, I did x first here, and that helps keep my equations lined up. X minus y
We have to erase this
equals 30. No, it's up to you. Or you can just add your notes. Why didn't you write down? I've changed it because lining up the x's and y's rather than cross it out or white it out. You write it down. I changed because. Then you know whether you need to or not. So remember, it's because lining up the x's and y's, just because I think that's what we're used to seeing, yeah? It's not necessary. We could have done y minus x, no problem, but anything that makes it simpler for us to deal with. Okay, so what do we do now? So we're going to try and solve it. So anyone want to decide a way, a method of solving it?
Well,
Substitution, elimination, equating both. Could we just put one equals the other in this case?
no.
Because
The two different things.
we've got two different values, so there's no equals the same number. If it was equal to the same number, we could, but the number's different, so we can't just write x plus y equals x minus y. So we're looking at substitution or elimination. Which one do you fancy? I know which one I would go for, but what about you? Elimination. Why would you choose elimination?
Because it's more accurate.
No. I would go with elimination because I've got the same number of x's and I've got the same number of y's. They're nicely lined up. I don't have to do any rearranging. You know, if I wanted to substitute, I'd have to rearrange one of them to be x equals or y equals. So I pick the method that gives me the least amount of work to do. Okay? So in my opinion, I've got them lined up. Do I need to multiply then? No, because I've got same numbers. So I've got the same number of x's and the same number of y's. Do you want to therefore add or subtract them? Okay, which one from which? 2 from 1. So 1 take away 2. So x take away x. Well, x take away x is 0. Plus y subtract negative y. So plus y subtract negative y. 2y is good. Lots of people would make a mistake. And then 45 subtract 13 equals
It's 32.
32.
Why did we say no to do that?
So I've got 2y's is 32, y is 16. Good. So we've got the first one. Now, the thing about these problem solving ones, quite often that to find the second part is really quick because there's always an easy one. So for instance, we know that the sum of them is 45, x plus y is 45. So x plus 16 has to equal 45. So x equals 29. 45 subtract 16 just in case. So there's my two solutions. Okay. So that's quite a common question, this whole two numbers add to make this, two numbers subtract to make this, or it could be two numbers multiply to make this one, and so on. Okay. So that's a common question, style of question. Do you need a moment to write it down?
Yes,
Okay, example 20, let's go through it. So it says, when shopping in Jamaica, 5 coconuts and 14 bananas cost me $8.70. 8 coconuts and 9 bananas cost me $9.90. Okay, so just make a sketch of that. So 5, what should I do for coconuts? 5C, okay. 5 coconuts, 14 bananas cost me $8.70. Okay, and then we say 8 coconuts and 9 bananas cost me $9.90. So if we add those together, it equals that. Are we okay with that? My question is, though, what does C and B stand for? Very careful. What does C and B stand for? X and Y? But what would X and Y stand for? We've used C and B instead, but C and B, like X and Y, was before X and Y was a number. But what is C and B? 1. Okay. This is an important point. What does C actually mean? So we said 5C, 5 coconuts. That's why we said it. But the trouble is that does lead to a misunderstanding by saying things like that. What does C and B actually stand for? But what does the 5 mean? Well, read the question again. The 5 is how many there are. There are 5 coconuts. Yeah? Well, what's the C? So it just represents the word coconuts.
How many coconuts?
How many? Well, I know there's 5.
No.
Someone said price.
Because it's 5 times the price.
C represents the price of 1 coconut. The reason why we know that is because look what it equals. It equals money. Therefore, there must be money on this side. Yeah? There's dollars on that side. Where are my dollars on this side? Okay. So C is the price of one coconut. B is the price of one banana. So we've got to be very careful how we think about writing down our equations using C's and B's and things, in that we don't think C means coconut and how many coconuts, because we know how many coconuts. How many coconuts have we considered in total though? 13, because 5 coconuts in one sentence, there's 8 in the other. We know how many coconuts. C is to stand for something we don't know. We know how many coconuts, so it has to be the price of one of those coconuts. We don't know the price of the coconut. Same as B is the price of a banana. So now we understand how can we go about solving. Now I'm going to make it slightly easier to deal with, but maybe you could tell me the effect of doing it. So I'm going to say equation number 1 is 5C plus 14B equals 870. Why have I done that? Don't have decimals, but what is the consequences of that? We could, but we don't actually need to. But this now is in dollars, therefore C and B will be in dollars. Okay? Whereas in this case, what have I turned it into? Cents. So if this is in cents, this is also got to be in cents. So don't mix up your units. Okay? So if you have a value at the end in dollars, your cost of a banana or a coconut will also be given in dollars. Whereas if we change it to cents, which is fine because it gets rid of decimals, C and B, when we find it, will also therefore be in cents. Okay? So I'll do 8C plus 9B equals 990. That's my second. Okay. Now you'll notice how in the example in the book they don't use C and B, they use X and Y. And the reason for that is because using C and B does lead to that problem that we had, which was considering C means coconuts, B means bananas. It causes that. So that's why they stuck with X and Y. But it's up to you. You can use any. Normally people try and avoid those letters that look like it would mean something else. So it's up to you how you feel happy. How do we solve it though? Elimination methods? Yeah?
And you could, if you have the same price, you are gonna subtract.
Okay. Do we have the same C's or B's?
No.
No.
You have to multiply.
We have to multiply. Yeah?
To multiply all these C's, all these B's, and all these.
So what do you want to multiply by, say? You want to make... There's lots of options, isn't there? So we want to make this 40. Okay. 40C, 40C. Okay, so what do we need to do to this line to get it to be 40?
Times by 8.
Times by 8. So we have to do 14 times 8. And we have to do 870 times 8. So if you've got your calculators, you can do that. So 112 minus 45, 67, you think? And 6960 minus 4950, 2010. So I want to find B, so I have to divide through by 67. So B equals 30. Oh, nice. 31.
$30.
That's an expensive banana. 30 cents, yeah. That's where it was important that we realise what we've done. So banana is 30 cents. How much is a coconut? Substitute it in. So 8c plus 9 times 30 equals 990. So I've used number 2. No reason, it was the one on the screen. So 8c plus 270 is 990. So afterwards, maybe too many colour changes slows you down. Do it afterwards. So how can we solve this one? So minus the 270. So that's 8c is 720. So divide through by 8. So that gives me 9. T. I guess, yeah. So C is 90 cents. Right. So I've got my 2 solutions.